A New York lawyer asked ChatGPT to help write a legal brief. It handed him 6 perfect court cases with names, quotes, and citations. There was just one problem. None of them existed. So before he filed it, he did the responsible thing. He asked the AI, straight up, "Are these cases real?" And it told him, confidently, yes. It even printed out the rulings. A judge fined him $5,000. So how does a machine this smart make something up this boldly, and then double down when you ask? We call this a hallucination, and you've almost certainly seen one. You ask a simple question, and the AI gives you a clean, confident, detailed answer that turns out to be completely wrong. The strange part isn't that it gets things wrong. Everything gets things wrong. The strange part is the confidence. It never seems to hesitate. It almost never just says, "I'm not sure." And that's the real puzzle we're solving today. Not why AI makes mistakes, but why it makes them so fluently, so convincingly, that you can't tell from the answer alone. To see it, you have to understand what one of these models is actually doing when it talks. And it's not what most people think. Here's the part that explains almost everything. A language model is not looking facts up. There's no library inside it, no database it checks before answering. What it actually does is predict the next word. It was trained on a staggering amount of text, and from that it learned, given the word so far, what word most likely comes next. Then it does that again and again, one word at a time, building a sentence that sounds right. So think of it less like an encyclopedia and more like the world's most powerful autocomplete. Its whole job is to produce text that's plausible. Not text that's true. Hold on to that difference, because it's the entire secret. Because most of the time, the most plausible sounding answer also happens to be the true one. Ask what the capital of France is, and the words that fit best are also the correct words. So it looks like the model knows things. But sometimes the smoothest, most natural sounding continuation just isn't real. A citation that fits the pattern of a real citation. A quote that sounds exactly like something that person would say. The model produces it with the exact same machinery and the exact same confidence as a true fact. The U.S. Government Standards Agency even has a cleaner word for this than hallucination. They call it confabulation. Confidently stated, but false. And here's the thing. The model is not malfunctioning when it does this. It's doing precisely what it was built to do. So why doesn't it just warn you? Why not say, "I'm not confident about this one"? Because it genuinely doesn't have a reliable sense of when it's guessing. The confident tone in the writing is not connected to whether the answer is actually correct. Now, that doubt does exist somewhere inside. Researchers publishing in Nature showed you can catch a lot of these by asking the model the same thing several times and watching whether the meaning of its answers wanders. When the model secretly isn't sure, the answers disagree. But the model doesn't tell you that. It just picks one and commits in the same steady voice it always uses. If this is already changing how you read AI answers, subscribe, because the next part is the piece almost nobody explains. Because there's a second reason, and it's not about the wiring. It's about how we grade these models. OpenAI's own researchers laid this out. The tests we use to rank AI models work like a multiple choice exam, where a wrong answer and a blank answer score exactly the same. 0. So think about what that rewards. If saying "I don't know" gets you 0, and a confident guess might be right, then guessing always wins on the scoreboard. We have, in effect, trained these systems to be good test takers. And good test takers never leave a question blank. It's the same reason you guessed on tests in school. A blank is a guaranteed zero, but a guess has a chance. We built that exact instinct into the machine, and then we're surprised when it never admits doubt. So now the opening makes sense. The lawyer's AI invented 6 cases because inventing plausible cases is exactly what a plausibility engine does. And it confirmed they were real because confidence and correctness were never connected in the first place. This is the idea to walk away with. In a language model, confidence and accuracy come from 2 different places. It is always confident, because producing fluent text is the one thing it always does. Whether it's accurate is a separate question it can't reliably check on its own. So a hallucination isn't a glitch that slipped through. It's the default behavior of a system built to always have a smooth answer and rewarded for never saying I'm not sure. So can't we just fix it? Patch it in the next version? Partly. You can hand the model real documents to quote from, which is how a lot of AI search works now, and that does cut the made-up answers down. But it doesn't erase them. Stanford tested legal AI tools that were sold as basically hallucination-proof, built specifically to ground every answer in real law. They still made things up between 17 and 33% of the time. 1 in 6 at best. So more data and bigger models help, and they're getting better. But because this comes from how the models work and how we score them, the researchers argue part of the real fix isn't bigger models at all. It's changing the test, so that honestly saying, I don't know finally stops being punished. So here's what actually matters for you. An AI hallucination is most dangerous exactly when the model is most useful. Specific names, exact numbers, quotes, citations, anything precise enough to sound authoritative and be completely invented. The fix isn't to stop using these tools. It's to remember what they are. Brilliant, fluent prediction engines that will never, on their own, tell you when to double-check. So you do it. For anything that matters, verify the checkable parts yourself. Now, there's a word people throw around for the moment AI supposedly stops making these mistakes and starts really thinking. They call it AGI. But what would that actually take, and are we anywhere close? That's next. I'll see you there.